G'day and welcome to another one of my videos. Today we're going to focus on finding the area of a kite and a rhombus, and we'll actually have a look at where these formulas come from. But first, what we'll do is we'll have a recap of what our definition of area is, and the area of a two-dimensional closed figure is the amount of space enclosed by that figure. So we've got a rectangle here, and this shaded part on the inside is what we classify as its area. So what we can actually do to determine the area of a particular shape is by counting squares within that shape. So we can cut it up into squares and then just count the number of squares. Now, because it's squares, we're actually finding all the measurements that we use are square units or units squared when we calculate that area. So that means if the dimensions were all millimeters, then we'd be millimeters squared. If the dimensions were centimeters, then it would be centimeters squared. So in this particular case, we've got 6 squares across and 4 squares up. So we've got 6 here, another row of 6. So we've got 4 rows of 6, and that's 24 square units. So what we'll do is we'll have a bit of a look at a rhombus and where the formula for the area of a rhombus comes from. So some of the facts about a rhombus is that all sides are equal and that the opposite sides are parallel as well. But there's some other facts we also need to know, that the diagonals are perpendicular bisectors. So bisect means to cut into 2 equal parts or to cut into half, and perpendicular means that they meet at 90 degrees. So that's what we've got there. So let's place in a diagonal. We'll call it diagonal 1. So there's our first diagonal, and we'll label that D1 as in diagonal 1. So what we've done is we've broken the rhombus up into 2 equal triangles. So remember, these 2 sides are the same, and so are these 2 sides, and this length here. So we've got a triangle, an upper triangle here, and a lower triangle there. They're both equal. So we know that the area of a triangle requires the base and the perpendicular height. So if we look at this upper triangle, we've got its base, but we don't have its perpendicular height here. Well, this is where the other diagonal comes into play. So if we put that second diagonal in, and we'll call it D2, okay, so the length of this whole diagonal is D2. Remember, if we use these facts up here, the diagonals are perpendicular bisectors. So that second diagonal is perpendicular to the first, and we'll put that in there just to help us. Okay, so let's just have a look at that upper triangle there. To find the area of that triangle, there's its base, and we've now got its perpendicular height there. But remember, we've just cut that diagonal, the whole diagonal was D2 in half. So this height of this triangle is actually a half D2. So let's put that in there so that we don't get it mixed up. Okay, so to find the area of a triangle, it's a half times the base times the height. So let's substitute that in. Our base is our D1, and our height is that half D2. And what we can do is we can simplify that expression. A half multiplied by a half is actually a quarter. So we've got a quarter D1 multiplied by D2. So we're multiplying the 2 diagonals together and then multiplying that by a quarter. But remember, that's just the area of that particular upper triangle. And we actually cut that rhombus into 2 halves, so those 2 triangles. So to find the actual area of the rhombus, we've got these 2 triangles, we've got twice that. So let's double that because we've got that upper triangle and that lower triangle that we had before. And so 2 lots of a quarter is actually a half. And so our area for that particular triangle, or so the whole rhombus, is multiply the diagonals together and then half that result. Or sometimes, instead of us writing D1 and D2, we use X and Y for the lengths of those diagonals. So in summary, to find the area of a rhombus, we just simply multiply the 2 diagonals together and halve that result. So we've got a rhombus over here, and if we put in 1 diagonal and we know that length, and our second diagonal and we know that length, then we can just simply multiply those together and halve them. Or we can actually halve one of them first and then multiply by the other. It doesn't matter, but there's our formula. Or sometimes instead of labeling them D1 and D2, we could label our diagonals X and Y and use this formula A equals a half XY. So you could see either of these particular formulas depending on what text you're using, etc. So we could do a similar thing for finding the area of a kite. Remember, multiply the two diagonals together and halve it is exactly the same as the area of a rhombus. So here we have a kite. If we put in one diagonal and then put in the second diagonal, now the diagonals don't bisect each other, but one diagonal does bisect one of the others. So this one here is actually cut into two equal pieces, and they do meet perpendicular as well. So we can use the same thing, so we could cut this into two equal triangles and use our diagonal one and our half D2 as the other one, exactly the same as we did for the rhombus, and then double it and get our half D1 multiplied by D2, so multiply our two diagonals together and halve it. Or again, and I've just rotated this kite around a little bit, we just multiply the two diagonals together, in this case labelled X and Y, and halve that result as well. So let's get into a couple of examples. So we've got a kite here on the left, and that's 10 for that whole length of the diagonal and 3 for the length of that diagonal. So to find the area, let's write the rule first, substituting what we know. So the two diagonals, 10 kilometers and 3 kilometers, and it doesn't matter if we put the 3 kilometers before the 10, we'll get the same result, and we end up getting 15 square kilometers. And for the rhombus over here, again, let's write the rule first, and we can substitute in what we know and work out our answer and get 7.5 square meters. But what we have to be careful of sometimes is that we might be given more information than we actually need. So make sure we're actually using the two diagonals, because sometimes we're told the lengths of the sides as well, and we don't need those to actually find the area of a kite or a rhombus. So this 2 and this 9 and the 2.9, we don't actually need those. So we'll just take those out just so we don't get confused. But if they are in there in a question, you can actually cross out those just so that you don't get confused with those. Okay, so what you now need to do is you need to practice and practice some more and practice again, and the more you do that, the easier it will become. So I hope you found this particular video useful and that you are finding maths and especially area a lot easier now.